Well, class, here we have another lesson on triangles. I told y'all before that you would be tired of triangles before this year is over with. There's still many more to come, but let's look at inequalities in triangles here today. Now, inequalities in triangles, when we're talking about inequalities, we're talking about less than and greater than and so forth. Um, but we have certain properties that go along with that. It says that if two sides of a triangle are not congruent, meaning they're of different lengths. So let's use the lengths of 5, 12, and 13. Okay? If two sides of a triangle are not congruent, let's look at 13 and 5. We know that they're not congruent. Then the larger angle lies opposite the longer side. Well, which is the longer side? Indeed, 13 is the longer side. So what that means in reference to this theorem is the fact that the angle opposite 13 is going to be larger than this angle here. So we can thus state that angle C is larger than angle B, right? According to this theorem here. Now let's also look at 12 and 5. Well, is 12 larger than 5? Well, indeed it is. 12 is larger than 5, so that means that angle A is larger than angle B. Angle A is larger or greater than angle B. So if we can list our sides in order, then we can also list our angles in order from either least to greatest. Now, if we're looking at greatest, my sides are, the longer side is AB, this next to the longer side is BC, and the shortest side is AC. Therefore, my angles from greatest to least would be listed as angle C, angle A, and then angle B, in that order. Here's my largest, and here is my smallest. Now let's look at that on the flip side. What do I mean? If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. Now, I chose 5, 12, and 13 for a specific reason. I know that this is a right triangle because 5, 12, and 13 form a right triangle. And this angle is, sorry, I just lost it. If I'm not mistaken, it's in the 20s. 20 degree. I want to say, we're going to call it 23 degrees. If it's not right, I'm sorry. I do apologize, but I just lost my mind for a second. But that angle is 23 degrees, and so that means that if we're following the reference of right triangles or triangles at all, we know that the sum of them have to equal how much? 180 degrees. So let's clean this up just a little bit. So if these three have to add up to 180, let's call this in 67 degrees. 67, 23 is 90. So then, let's think about it this way. If this is my largest angle, which the right angle of a right triangle is always larger, what's always the longest side? It is the hypotenuse, which in this case would be 13, and 13 compares to AB. So which is the next to the longest side? Well, 67 is after 90, so that means that BC is next. And then, of course, my short end is AC. Notice the relationship that the letters, the three letters, form the triangle. Here in this case, we have B, A, and C, B, A, and C, A, B, and C, and C, B, A. And you're thinking, what? Yes, if you list the angles in order and the sides in order from greatest to least or least to greatest in the same amount, then you will hit all three letters. If you do not, then you have done something wrong. So inequalities of triangle, if two sides of a triangle are not congruent, then the largest angle lies opposite the longer side. It's just pairs. Notice that the big people go with the big people, and the little bitty people go with the little bitty people. That's how it works in this triangle. But let's take it a little bit further. Okay? Now, I can give you any three random links, but do they all three form a triangle? Well, not every set of 3 segments can form a triangle. The lengths of a segment must be related in a certain way. Now, what are we talking about? Well, if I told you, hey, take the lengths of 2, 2, and 5. If you had straws that were the length of 2 inches, 2 inches, and 5 inches, there's no way possible you could form a triangle. Wouldn't work. If you had 2, 4, and 5, yes, indeedy, that would work. 2, 2, and 5 would not. 2, 4, and 5. Even 2, 3, and 5 would not work. Why is that? Here's the reason why. Because the sum of the lengths of any 2 sides of a triangle is greater than the length of the third side. When you add 2 sides, they have to be larger than the third. Notice 2 plus 2 is not larger than 5. In this case, 2 plus 4, it's larger than 5. 2 plus 3, it's not larger than 5. It is equal to, but it is not larger. And it tells us that it has to be larger than the third. So looking at such, can we form a triangle with the lengths of 6, 12, and 17? We want to look at it. We can, it says any 2 lengths, we can customarily say, hey, 6 plus 12, that's more than 17. 12 plus 17 is more than 6, and 6 plus 17 is more than 12. If we add, the key thing is to find the 2 smaller ones. If those 2 are greater than the third, then it'll check out. You don't have to do all 3. So what if we have, let's say we have 15, 8, and 20. 15, 8, and 20. Well, find the 2 smaller ones. Well, that's 15 and 8. What's 15 plus 8? Is it greater than 20? Well, 15 plus 8 is 23. 23 is greater than 20, so hey, I can form a triangle with that set. What about, let's say, no, let's not use that. What about 3, 3, and 3? It's an equilateral triangle, right? Indeed it is, because all sides are the same. 3 plus 3 is greater than 3 itself. So the sum of the lengths of any 2 sides of a triangle is greater than the length of the third. Always, always, always. I can always form a triangle when the 2 sides are greater than that third side. Well, now let's take it one step further. Find the possible lengths of the third side of a triangle given 2 sides. What if I tell you that I have the 3 sides? 3 random sides. One side being, let's say, 6. The other side is 8. We want to find x. What are the possible sides for x? Now, we can sit here and we can, I like to first look at it as a number line and think of the possibilities of that. And this is a way for you to see it. Is this the way we need to do it? By all means, no, it is not. What am I talking about? Well, let's start putting some lines here just to represent points on a number line. And since all of our lengths have to be positive, we're going to start at, let's say, 0. There's 0. So here's 2, 4, 6, 8, 10, 12, 14, 16. Here's 18, 20, and 22. Now, I don't need all of these, but just so we'll see. Let's go through and let's think about what do we have to do. Remember that the sum of 2 sides have to be greater than the third. So what are possibilities for x? Could x be, we know it can't be 0 because it wouldn't be anything. But could x be 1? Well, is 1 plus 6 greater than 8? No, it is not. So wouldn't work there, right? What about 2? Is 6 plus 2 greater than 8? No, it is not. So 2 does not work. What about 3? 6 plus 3. 6 plus 3. That works, doesn't it? 6 plus 3 works. Because 9 is greater than 8. Well, what about 4? Well, 6 plus 4. Yeah, it's 10. 6 plus 5. Yeah, it's 11. 6 and 6 is 12. All of these are greater than 8, right? And so you're thinking, I think a lot of you are thinking, hey, well, then that means that it's all of these numbers here that are greater than 3. Well, let's look at it a different way. Let's look at, say, 20. Looking at 20. 20. And you're thinking, well, what does that mean? Well, 20 is 6 plus 8 would be what? 14. Well, 6 plus 8 would have to be greater than 20. So guess what? 20 doesn't work. Could I add 6 and 8? No. Well, we've already added it to be 14, right? But is it 14 itself? No, it's not. But it's all of these underneath it, right? But let me ask, is it just the numbers to that point? No. And you're thinking, what in the world? Look at it this way. Could I not go to, change pen, sorry about that. Could I not say 2.1? Is 2.1 plus 6 greater than 8? Yes, it is. It's 8.1. And what about here? Could I say 13.9? Would that work? It would indeed work. So here's the easy way. How do we find x? In order to find x, you must say the difference of the two numbers. So 8 minus 6, that's 2. But you're thinking, well, 2 doesn't work. Yeah, hold on. And add the two numbers. 6 plus 8. I don't know why I reversed them. And form an inequality. So 2 and 14 going that way. What does that mean? X is greater than 2. That's what that means. And x is less than 14. It has to be greater than, and it has to be less than. Those two different numbers. 2.1. And now understand that we could go 2.0000000 long, long ways until we get to 1. And guess what? It'll still be greater than 8. And that's the reason why we use the inequality symbol. Because 2 is less than x is less than 14. So let's clean this up just a little bit. So I'm going to erase. Give you a little second to get everything down. Now let's really fix this. Fix this on how to clean it. Well, no, we want to erase. We don't want to move it around. We want to erase. So here's the way we actually can work this out. So we know we're looking for x. So in order to find x, we're going to say 8 minus 2. 8 minus 2. I apologize for that. 8 minus, well, obviously I can't read and write at the same time tonight. Yes, it is night time with me writing this. 8 minus 6 is less than x is less than 8 plus 6. So what are we doing? We're taking the difference of the two numbers and the sum of the two numbers, which gives us 2 less than x less than 14. Very nice. So, real simply, keeping that same process in mind, we have the two numbers. We have 14 and 20, and we want to know the possibilities for x. What are the possibilities that x could be in order to form a triangle, any triangle? Well, we're going to take the difference of the two numbers and the sum of the two numbers. 20 minus 14 is 6. 6 is less than x, which is less than 34. So all of my possible numbers for x are in that range. And that's how the inequalities of triangles work. So we can list angles in order, we can list side lengths in order, or we can actually determine if the segments do indeed form a triangle itself. So, hope everything is a little bit more understandable now. If not, maybe you have time to go back and just rewatch as you are focusing on what's going on and not just writing and watching it at the same time. See you soon.